regarding the chemical energetics. For the calculation of the delta H, we have one of the way is Q equal to mc delta T, and also this is delta H, enthalpy change of reaction, delta HR. So let's start. Basically, in this question, we are going to learn whether the reaction is exothermic or endothermic. Burning of magnesium, exothermic. Crystallization of copper sulfate, exothermic. Thermal decomposition of magnesium nitrate, endothermic. And the fermentation of glucose by yeast, exothermic. Evaporation of seawater, endothermic. Okay. Then we have energy reaction pathway. This reaction pathway and this one, basically the combustion of sulfur. This is exothermic reaction. So we have a pathway in which the reactants will be on the upper side and products will be on the lower side. Activation of energy is lesser and delta HF is greater. For the second one, this is endothermic reaction in which reactants on the lower side and products on the upper side. In this one, the activation energy is a bit greater. Then in this one we are going to identify each of the following. So it is delta HR for this one, delta HF or delta HC for this one, delta HR for this one, and delta HF for this one, or we can also call it as delta HC. You should remember that if there is an oxygen is going to be added in any reaction, that can be considered as enthalpy change of combustion. Now we have different kind of question. The first three question are through the formula Q equal to mc delta T. The answers are here. Simple mc unity, I have put in the values and we got the value in the joule. You should know that for water the energy will always be 4.18 joule, 4.18, 4.18. Delta T is the difference of the temperature. For regarding question number 5, explain why enthalpy change of neutralization of 1 mole sulfuric acid is not the standard enthalpy change of neutralization. The reason is here, 1 mole sulfuric acid had to be 2 moles of sodium hydroxide to form 2 moles of water. So definition of standard enthalpy change of neutralization relates only to 1 mole of water formed. So the enthalpy change of sulfuric acid twice this. Then question number 6, student added 10 gram of sodium hydroxide of water to 40 cubic centimeter of water to make concentrate solution. All the sodium hydroxide dissolved. The student measured the maximum temperature rise. The student suggested that these results would give an accurate value for the standard enthalpy change of solution. Give two reasons why the student is correct. So time taken of sodium to dissolve loss to the thermometer air of the calorimeter. Assumption that specific thermal capacity of the solution is the same as that of water. And the last one, student calculated standard enthalpy change of combustion of ethanol by calorimetry is minus 870, but while in the data booklet it is minus 1367. So why the difference? Basically, in an experiment there may be heat loss to the surrounding from the flame and into the calorimeter thermometer air. So incomplete combustion of the ethanol can also be a reason. Okay, now this is another example in which we are going to calculate the enthalpy change of reaction of sodium hydrogen carbonate. It will be converted to sodium carbonate, condensate and water. The cycle for this one is given here. This is the cycle for this one, and all the values are given here. While the solution of this question is here, we will first of all apply delta Q to delta H1 plus delta HR, and then delta HF plus delta HR. So we just put down the values and we got here plus 91.6. This is the value of delta HR. So this is the solution for the question number 1. And then calculate the standard enthalpy change of formation of ethane. For this one the energy cycle will be this one, and for this question the energy cycle is given, the Hess cycle is given, which is this one. Right, for solution 2, this one. Basically you can see here when we put down the values and delta, you can see here delta H1 equal to delta HF plus delta H2, obviously through this one. And what we are going to find out, so we are going to find out delta HF. So delta HF will be equal to delta H1 minus delta H2. So when we put down the values, we got this minus 84.7 kilojoule per mole. Question number 8. All the question is given. We just draw the cycle Al plus Fe2O3, Fe plus H2O3. It is delta H1, it is delta H2, this is delta HR. So delta HR will be equal to delta H2 minus delta H1. By putting the value, we got 851.5 kilojoule. In question number 9 and question number 10, the solutions are here. This one is the solution, the Hess cycle, the above reaction. Question number 9. For question number 9. And in the question number 9, we got delta HF, which is 277.1 kJ per mole. For question number 10, which one of the following gives a correct value for enthalpy change of this reaction? It is delta HR equal to D, delta HF minus delta HF Fe2O3. Question number 11. So question is given, the values are given, all the values are given. So delta HF plus delta H to delta H atomization. We are going to find out the delta H here, delta H to delta H atomization minus delta HF. By putting the values, we got 1663.5 kilojoule per mole, but as it is for the methane, so it have to be divided with the 4 to get for one CH bond, and it is 415.8 kilojoule. Right. Is a question number 12. For the question number 12, basically for A and B, we have the solution here. For the A, we just need to write down the equation like this in the bonding form. For the B, we need to put up the values, which I did just put the values here, and then find delta H C, which is minus 1324, sorry. Also for the 12, we have done the 12AB. For 12C, the bond energy is on the basis of the gaseous reactant and products, while in combustion of the ethanol, ethanol is a liquid. In 13, question number 13, which one of the following statement completely correct? So 4 CH bonds and 2 O bonds are broken, and 2 CO bonds and OH bond are formed in this equation. So B is correct. Right. This is a question from a paper actually, which is described, in which we're going to find out the amount of the energy enthalpy change, and it's simple. Here we have 4 moles of ammonia, so divided by 4, and this value is for kilojoule per mole. So but this value is for calculating kilojoule per mole, we need to divide it with 4. Then this one, 2 moles, so divided by 2. Here 4 moles of NO2 divided by 4, and then we need to add all of them, and we got minus 370. And that's it. This is the end of the today